Hello everyone, can you hear me? And can you see my screen? Okay.
Yeah, sir.
Okay, sir. Okay, so let's begin. Still me, Jim. And today our topic is about this one, position control. And here you could see here have 5 parts we need to I will introduce today. Okay, first part is position control introduce. The position control mode is widely used between 3 control modes about our server. You know, our server have position control and speed control and torque control, and the position control is the widely used one. And we use this to do some positioning applications. PLC will send posts to our server, and the server driver will receive the post and to rotate. And for the distance and the speed it depends on the post number. Distance depends on the post number, and the speed depends on the post frequency. Okay, so in PLC we can use some position instruction to control our server to move. So you can see this picture here, DRVI. This instruction is a relative move instruction. And here we enter the post we need to send, and then the frequency we need to send to control the server to move. In server, we have a parameter. This one P0 and 16. This parameter will determine how many posts can make our motor to rotate one circle. And this value default is 1. You can see here. And here, this parameter default value is 10,000. 10,000. It means when PLC sends 10,000 pulses to our driver, the driver will control the motor to rotate one circle. Okay. And for the speeds, you can see here the frequency is 2000. So it means PLC will spend about 5 seconds to send 10-second pulse. So it means our motor will rotate one circle within 5 seconds. So this is our speed. And not only this one, there are also other position instructions. I think before we have PLC training, and there we have already introduced most of them. So for example, DRVI, DRVA, and PLSY, PLSR, and so on. So many instructions to can set the pulse to control the servo. And this is how position mode works. This curve. Okay, we can just take a look. And some application, especially this ECAN application. This ECAN application, we need to use our servo in position mode. But for ECAN function, this function is dependent on PLC. It's dependent on controller. So for servo side, we just need to set it in position mode. And the second part is about position command source. For this parameter P0 and 1, this parameter is used to set the control mode. You can see position, speed, and torque. And also we support mixed control. For this mixed control, it means we can select two control modes among these 1, 2, 3. Select two of them and to be a group. And for example, if we select 4, it means the servo will work in position mode as default. And if there are an input signal give to our driver, the driver will change the working mode from position to speed. So we can use an external DI to change the control mode between position and speed if we set this parameter as 4. And the 5, 6 is set. Okay, this is control mode, and the next one is this position command source. You can see here we support two modes. 0 is post command. It means in these modes, our servo need to connect to PLC and receive the PLC pulse to work. But if we select this parameter as 1, it means our driver will work in internal position commands. So we can set the target position, target velocity, and the target speed, and for example, some wait time between two move segments. We can set some motion parameters in our servo directly, and servo can working. So we can work according to these motion parameters without PLC. But please notice here only these two. Not all firmware supports internal position modes. For VD2 series, only firmware V1.1 and above support internal position mode. And for VD2F, only V1.0 and above supports this internal position mode. Okay, next part. This one. P0 and for this parameter is used to change the direction of our motor. Yes. This one is easy to understand. And next, for this P0 and 12, this parameter is used to set the position post type. For example, if we set the position source as post command input, then we need to set the post type. If you connect Servo to Wacom PLC, usually we use first default one, direction and the post. Use this post type to control. Here, first picture. This picture you can see Y0 is sending the pulse, and the Y1 is the direction signal. And then the second picture, second GIF, you can see also Y0 is sending the pulse, and the Y1 is direction signal. So you can see these two status. Is two working direction, forward and the reverse. No, not only Y0 and Y4. It's depend for post outputs, we need to use high-speed outputs. It's depend on PLC. For example, usually for 3V, we only have Y1 and Y0 support high-speed outputs. So for 3V, we need to use these two terminals as post. And for 5V, for example, 5V and 24 and 16 for this module. Y0, Y1, Y7 as post. It depends on PLC. You just need to remember that we need to use high-speed output terminal connect to our server post terminal. And for direction, we don't need high-speed output. So you can use maybe Y10, Y20, or 21, 22. It's dependent on PLC. Okay, this is the default working post type. And also you can see here have CW, CCW, different post working type. Okay. And here I mainly introduced the first one because our PLC usually working in this mode. Okay, next here is the waveform about two different working direction. First one is forward moving, and the second one is reverse moving. And this curve is the speed. Next one. Here is about how to value between control device and our servo. Usually the control device we use PLC. Yes, because usually we use PLC to send pulse. And here have two different connect type. First one is differential input, and the second one is open connector inputs. For these two different inputs, for these different post output type, we need to use different connecting. And for VD2F value is same with VD2. The only difference is about is the pin number. Pin number is different, but the terminal name is same. Okay, we can check this picture. This picture is more easy to understand. So here, this is Wacom PLC, and here we connect Y0 to our post inputs. Here we need to we connect to pin 42, not pin 43. Please note this point. And for direction, in this picture, in this example, it uses Y4 to control the direction. So we connect Y4 to pin 40. Also, we connect to SIGN pin 40, not 41. So this point also please note it. And after these two, we also need to connect an external 24 voltage to our pin 44 to this PL terminal. So we can see here we need to connect 3 cables between servo and servo driver and PLC. And in PLC sites, we also need to connect the subcom ports to our main COM ports. You can see here we need to connect COM3 to COM1, to COM0, and connect COM0 to COM. Okay, this is how to connect Wacom PLC and our Wacom and our driver. And here, for now, our PLC is only supports NPN output, so we use this connect type. And maybe when you connect our driver to maybe other PLC which is supports PNP outputs, you could check this picture how to connect. Okay, so here we just take a look. So I mean for driver it supports both PNP and NPN inputs for driver, but our PLC only has NPN output now. This is about how to connect, and okay, and the next part for this parameter is used to filter some noise, some interference. And how to understand? For example, before here we have a picture. Before filtering, you can see here have some small poles like this. If there are some interference inside, the poles maybe will change to like this one. So it will have influence. It will have effects about our position control. For example, here we should send only 3 poles to our driver, to our servo. But because there are maybe some interference to get like this, so we will get 1 pulse, 2, 3, 4, 5. The pulse will change to 5. So the driver will receive 5 pulse, and it will make motor to rotate to move a longer distance. This is what not what we want. So with this parameter, we could filter this pulse caused by interference. Okay, and but how to set this parameter? We can check this example. For example, we use our PLC is using 10 100,000 is working in this frequency. So we can calculate that about for one pulse, the cycle is about only 10 ms. So so the pulse width should be only 5 ms. So wait, that means this one is 10. So for this one is about only 5 this time. So we can set this. It means for the cycle, for the pulse, which the cycle is smaller than this value, then it will be filtered. So with this setting, we can ensure that our normal pulse will be remained, and for some small pulse maybe like this, which is smaller than 4.0 and then 4.096 will be filtered. So we will not get this part and remain our normal pulse. So this is how this parameter working and how to set this parameter. Please notice, don't set this parameter to how to say don't set this parameter too big. For example, if we set this big, then our normal pulse will also be filtered, so we will get nothing. Okay, that's only this only one point need to notice. Okay, do you have any question? Okay, we continue. And for this parameter, I have introduced this one in the beginning. This one is determines how many number of the pulse per turn of our motor, PPR. And for these two parameter is EG setting of our driver. So for these two, 1, 2, we can only select one way to set PPR of our driver. If we use P0 and 16, then this 17 and 18 will not work. And if we want to use 17 and 14, use these two to set the PPR of our driver, then we need to set P0 and 16 as 0 first. So it means only when this value is 0, then P0 and 17, 18 will work. Okay, so here have a question you can see. For example, we use a 17-bit motor, and our store pitch is about 6 mm. So how to set the pulse? How to get this one? How to set the pulse equivalent to 1 mm? This is our question, and on the right side you can see here I have two way to set it like this one. First way, we use P0 and 16 to set, because here we can see the one revolution of our motor is this value, is this one. And if you want, for example, if our reducer without reducer, so this is 1.1. So we can set P0 and 16 as 6,000. So in this at this time, when our driver receives 6,000 pulse, and this one will move 6,000. We will move this distance, 6,000 pulse. So with this setting, we can see we can get this result. Okay, this is the first setting. For second way, how to set is we use EG radio to set. How to set for parameter? First, we need to set P0 and 16 as 0 first. And second, we set 0, 17 and 18 as these two parameters. But here, why I can get this parameter for these two? How to set these two? We can check, continue to check. Here is the steps about how to set the EG to get the relationship between pulse and distance you want. So you can check these steps here, and here we have one case, calculate case. We can check it. Okay, this one. Step 1, we need to set this value as 0 first. And the second, we need to calculate how many pulse requirement for one revolution of our load. And we set this parameter as A. For example, if our PLC sends 10,000 pulse to servo, and we need our load move only 100 mm, and the move distance of our load in one rotation is 300 mm. For this value, we can use tool to check it. So yes. So we will get how much A is. It's about 30,000 pulse for one rotation. This is the A, how much the A value A is. And and next part, we need to check how much B is. This is easy. It's only depends on our motor. For this encoder, B is 2,500, and for 11 bits, B is this value, and for 24 bits, the value B is this one. So okay, so now we get A and B. And the next part, next step is to calculate the next part is to set the reduction ratio C. This parameter is spent on our reducer. If we didn't connect reducer, then C is 1. And if the reducer is, for example, this ratio, motor rotates 24 loads and lot rotate one rotation. Sorry, here is rotation. And it means C is 0.04. Okay, so now we get A, B, C. And at the same time, we will get how much our P0 and 70, and how much P0 and 80, how much these two value is. We can set this one as B and set this one as this one. Yes. Okay. So this is these are two-way to get this setting. Next part is about post-frequency division outputs. Because our driver can output the encoder signal, but the signal type is this one, post-frequency division outputs. So we can't connect this signal to our to Wacom PLC directly, because Wacom PLC don't support division signal inputs. So we need to connect convert boards to convert 5 voltage divisional signal to 24 voltage connector signal. So here you can see this on the top is our connector signal. So we can connect AB phase, connect to our PLC inputs, high-speed input. The connection is like this. So if you want to, for example, if you want to check the position or check some position error, you can connect this pin number, this pin to this converter and connect converter to our PLC and use PLC to check whether the encoder value is normal. For example, if we send 1,000, if we send 10,000 posts to driver, and here we should receive 10,000 posts from our encoder. Oh, sorry, not 10,000. It depends on this parameter. The number of output posts for one circle of the motor. Default is 2,500. So it means the motor is rotate one circle, the encoder will feedback 2,500 pulse to other device, for example, to our PLC. And next part is about some commonly used DIDO. First, for DI, you can see here we have many DI inputs, channel function, and these two parts is commonly used DI. For example, servo enable and alarm clear, and forwards driver prohibition and reverse driver prohibition. Pin number and its default function. You can see for VT2 series, we have 8 DI input, and for each DI, we can select different function. Connecting. Here, for example, for DI1, we need to connect PLC output to DI1. Here we connect Wi5 to pin 9. And at the same time, we need to give external 24 voltage to our SS, to our pin 8. So here we connect 24 voltage to SS. So in this time, when our PLC have outputs Wi5, if the Wi5 have outputs, then the servo will receive it and to release some function. Here I have connects. Here in PLC, I connect Y2 to our servo. So here you can see here when Y2 have output signal, the driver will change to wrong status. And then now when Y2 without outputs, you can see our driver will change back to ready status. This parameter 2 means ready and 3 means wrong status. Okay. For DI setting, there are 3 relative parameters. First one is DI function codes. DI1, for DI1 function codes, we default is used to enable the servo. So it is the default value is 1. And we can also set it as other function code according to the requirements. And the second step is to set the DI function codes to set the channel logical, sorry, to set the channel logical. Yes. So here we have two logical. Default is 0. It means when our PLC have output, then servo will enable status. If we set this parameter as 1, then the result will be different. It means when PLC have no output, then our driver will in wrong status. And when servo have output, our driver will in ready status. So this we can see these two logical is different. And the last part, last setting is about DI input source selection. You can see here have hardware input and virtual inputs. if we connect PLC to driver to enable the driver, then we need to select first one, hardware input. And if we use a virtual input, it means there are no hardware connecting. So in this way, how can we change the input signal? Here we can see we have group 13 group, and here we have virtual DI inputs. So we can use this parameter to change the input status 0 or 1, and to enable or disable our servo. And for this parameter, in the last class, I said for this parameter we can use Modbus RS485 to change this parameter, to change this value. So it means if we use virtual inputs of our DI, we can use HMI to change this value, to enable or disable our servo. You can see there are no PLC, no hardware connecting for DIDO. Oh. Okay, and the next part is some commonly used DO. For example, servo ready, and the servo alarm, and the servo positioning complete. This is DI pin number. You can see VD2 series supports 5 DO. And this is the wiring between PLC and the servo. How to connect DO, servo DO to our PLC inputs. There are two wiring between servo and the PLC. First, we need to connect DO post to our X inputs. Here we use X0 to receive the DO1 signal. And second, we need to connect DO1 this one to our another pin number to our COM port. So this is the second connection. And at the same time, we need to connect 24 voltage to our PLC input side. Okay, here I have one question. Is it possible to connect code out terminal of the servo? Yes, but we can connect, but we as I said, we can't connect directly. We need to use this board. This board will convert the signal from driver from frequency division signal. Will convert this signal to connect the signal, which can be received by our PLC. And if you don't have this convert board, in fact, we have another type of driver, it's H series of the VD2 SAE. For example, So you can if you want to use this function, you can buy this serial driver, H serial. H serial can directly output connector connector output signal, and this signal could directly connect to our PLC. So with this serial PLC, with this serial driver, we don't need to connect such a convert board. Okay, continue. Here after connecting, there are some parameter setting about our DO. First, we need to select DO function code. You can see here we have so many function channel, and you can select one to use. And the next step is to set the channel logic about our DO, and this is same with DI. You can see these two different logic. The results will be different. And also there are one point need to notice is we can't set 2DI or 2DO with same function code. For example, if we set DI1 as function code 1, and if we at the same time if we set DO2, if we set DI2 also as function code 1, our driver will report an error. Also, if we set 2DO, ports channel function as function code as this 1132, our driver will also report an error. So it means different DI should use different function codes. Okay, and the last part is about some questions about in position mode. First is for example, first question is motor can't rotate. So for this question, there may be many reasons. First reason is parameter setting error. First, you need to check the control modes, P0 and 01. It should be position mode. And the second, we need to check the servo status. Only when servo is in run status, the motor can run. And the second, we need to and then last, we need to check the command source, because our driver supports two command source, host commands and internal commands. If you set it as internal command source, then your PLC setting post will not able to control the motor to rotate. And if the parameter setting is normal, then we need to check the PLC sites to check the input commands. First, we need to check PLC's post setting is normally, and the servo is receiving the post normally. For how to check? First, for example, when PLC is sending posts, the output's Y terminal should be fresh. Yes. And in several parts, we can use this here, this monitoring value U0 and 3. This one input speed commands, and also these two. We can check U0 and 8, U0 and 9, these two parameters. And the second, we can check the PLC to check whether our driver is receiving the post normally. If here have no value, it means our driver didn't receive the post. So of course the motor will not rotate. So maybe you need to check the value or check the PLC sites whether it is sending post normally. And another reason is about the analog inputs. How to say? When our driver is working in speed mode or torque modes, we can use analog inputs to control the speed or control the torque. So if the analog input is abnormal, our motor will also not rotate. And the last reason is maybe there are some mechanical blockage or some or not connected. So in this way, in this situation, we need to check whether the load is connected normally, whether the load or whether there are some mechanical stuck, and also for some motor is with brake device, we need to check whether the brake device is released is released or not. And the second question is about sometimes maybe motor can only rotate in one direction. For this, usually there are control commands question. For example, PLC sites, you are using a single direction instructions, which don't have direction outputs. So we need to check the control command first, and if the control command is normally, maybe another reason is our driver side pin is damaged. So we can use jog function to check if a jog function can work normally when forward and reverse. Then it means our direction pin maybe have some question. So you can contact our engineer to check it. This one is this terminal. This one. This terminal is our direction terminal. So maybe this terminal have some question. It can't receive our direction signal, and cause our motor can rotate only in one direction. Okay, that's our today's content. Do you have any questions? Today we introduced the many parameters in our position mode, and also we introduced how to connect pulse signal, the direction signal, how to connect DI and DO. When do we have our homework feedback? I would usually within 2 or 3 days, because some people may submit the homework not so quickly. So within 2 or 3 days, we will send feedback to all people who submit the homework. And the last, we will also arrange one class to how to say to answer the questions about homework. And the last class we will arrange one class to do it. Not 3 days. It depends. Maybe 2 days. It depends on because depending on work. Because sometimes maybe have some works we need to finish it. So we couldn't feedback or homework immediately, but we will give the feedback of your homework as soon as possible. Okay. Okay, so this is our today's training. And later I will also send the training video and the presentation and the homework to our training group. And please receive it and check the homework and submit it as soon as possible. Okay. And if you have any questions about homework or any questions about the training, you can discuss or ask me in our training group. I will reply it. Okay. Okay, thanks for your time and at the same time tomorrow. See you tomorrow.